Okay, so for this problem here, we are going to try and solve it, determine the enthalpy of the reaction. So the first thing we want to do is look over the question and see what information is given. So we have 60 grams of sulfur trioxide that completely reacts with water to produce sulfuric acid. Determine the enthalpy of the reaction. So that's what they want us to find. So the first thing you want to do is write down the information that's given, which is 60.0 grams of SO3. And we know that it reacts completely. And then they want us to find the total enthalpy of the reaction. Okay, so first of all, the steps to take is to find our delta HF would be, well, to know what the formula is. So it's the sum of the delta HF of the products minus the sum of the delta HF of reactants. So in this case here, we have our H2SO4, or sulfuric acid. So we need to, it'll be that H2SO4 minus the delta H of SO3 plus the delta H of H2O liquid and gas and liquid. So in this case here, we have to look at the standard formations. So you can use the table in the back of your book. I have one right here. So H2SO4, it's minus 811.3. kilojoules per mole minus, and then SO3 minus 395.2 kilojoules per mole plus H2O. I have liquid minus 285.8. Alright, so now all we have to do, since there's only 1 mole of each, we multiply all these by 1 mole. So it's actually 1 mole times negative 811.3 kilojoules per mole. So that'll cancel each other out. Minus 395.2 kilojoules per mole times 1 mole, since we only have 1 mole of the SO3, plus 1 mole of water times minus 285.8 kilojoules per mole. So the moles will all cancel each other out, which will give us minus 811.3 kilojoules. And then we have minus and minus. Well, we'll just keep still like that. 395.2 kilojoules minus 285.8. So that's because we have a minus here. Kilojoules. So this will give us gives us minus 130.3 kilojoules delta H. So what does that mean? That means when 1 mole of sulfur trioxide combusts completely, it releases 130 kilojoules. But now we have 60 grams of SO3, and we know that the molar mass is equal to 32.06 plus, well, 3 times 16 grams. So that's just the S, and then this is the O3, which gives us something that is 80.06 grams. So now we want to determine the number of moles. So how do we do that? Well, simple ways to create a ratio. So we want to know X moles over 60 grams is equal to 1 mole over the molar mass, which is 80.06 grams. And then we're just going to multiply and divide. So 60 times 1 divided by 80.06 gives you 0.749439 moles. So in order to determine how much energy is released, well, you're going to do the number of moles times your delta HF, which will be, so this number here times that, which will give you minus 97.651758 kilojoules.